Hey guys, I am Jennifer, 3D animation fan, and I'm glad to see you again. Before we start, please subscribe to our channel to encourage me. Today we're going to talk about a wonderful subject. Ready? Let's go. When it comes to building skyscrapers, there is no piece of construction equipment more essential than the tower crane. These heavy lifting machines dominate city skylines, hoisting materials and machinery to some of the highest construction sites on Earth. They have become a part of everyday life in almost every major city as contractors race to build high-rise after high-rise, and more than 100,000 can be found in operation around the world at any given time. Despite how common tower cranes are, they often seem to appear in the sky out of nowhere, leaving many of us wondering how they got there in the first place. The vast majority of tower cranes are erected using mobile cranes that are larger in size, but obviously this cannot always be done when you are building a record-breaking structure, and taller cranes simply don't exist. Some construction sites in dense urban areas may not have enough space for a large mobile crane either, and many projects also require tower cranes to be erected in stages so that they rise in unison with the constructed portion of the building. In these scenarios, the cranes must raise themselves to the final working height all on their own, using a method known as climbing, and that is what we will be looking at in today's video. In general terms, climbing a tower crane simply refers to the process of adding or removing sections of the mast in order to increase or decrease the overall height. The concept is fairly straightforward in principle, but it is quite difficult to execute safely in the field, with catastrophic consequences if anything should go wrong. It is one of the most dangerous operations that can be performed with a tower crane, and it is only carried out when absolutely necessary to complete a project. Before climbing can begin, a tower crane must first be erected to an initial height using a suitable mobile crane. The process begins by constructing a stable foundation, which usually consists of a large concrete slab reinforced with steel rebar, and this takes place about a month before the crane goes vertical, so that the concrete has enough time to cure. Once the concrete has reached its full strength, the first steel truss section of the mast is lifted into place, and it is secured with anchor bolts that are embedded in the foundation. Additional sections are then stacked on top of one another to complete the tower portion of the crane, and they are fastened together with high-strength steel bolts. The mast is topped off with a slewing unit, which is basically a turntable that allows the top of the crane to rotate, and this serves as a base for the operator's cab and lifting components. The tower crane, but the one shown here, has a hammerhead configuration with a cathead and a fixed jib that cannot be moved up or down. The cathead is the first component to be installed on top of the slewing unit, followed by the counter-jib and working jib. And these are connected with steel tie rods that help to transfer loads to the mast. Once the top assembly is complete, a counterweight is then added to the counter-jib, which normally consists of several concrete slabs. Now, up to this point, we have only talked about tower cranes that climb externally on the outside of a building. However, they can also climb internally on the inside of a building. In this scenario, the weight of the crane is carried by the constructed portion of the building, which can increase the lifting capacity and reduce costs by eliminating the need for a tall mast. The process begins in the same way as before, by erecting a crane on top of a concrete foundation, but the tower must now include a climbing section at the bottom that will be used to lift the crane later on. As the building is constructed around the mast, two steel collars are installed approximately 3 stories apart, which connect the crane to the building's structural system. Climbing rails extend between the collars down the inside of the open shaft, and these provide support for a hydraulic jack that is positioned inside the mast climbing section. When the crane is ready to be climbed, the tower is unbolted from the foundation, and the hydraulic cylinder is pressurized to take its weight. The cylinder is then used to lift the crane upwards until the bottom of the mast reaches the first collar, while a ratcheting system ensures that the crane cannot fall back down the shaft. As additional floors are added to the building, a third collar is installed 3 stories above the first 2, and the crane can then be lifted from the bottom collar to the middle one. At this point, the bottom collar is no longer needed, so it is removed and relocated another 3 stories above, thus allowing the whole process to be repeated as the building stretches higher. When construction is finally complete, the tower crane will either be disassembled using a larger mobile crane, or a smaller crane will be hoisted to the top of the building that can be dismantled by hand once the tower crane is removed. Tower cranes play an essential role in countless construction projects all around the world, and their ability to climb upwards entirely on their own means there is virtually no limit to how high we can build.